Hello students, welcome to chapter 11, 3-dimensional geometry. Students, today I continue our plane in the space related exercise 11.3, question number 3. Find the Cartesian equation of the plane for the following given planes in the way of r dot I plus j minus k is equal to 2. Very easy students, I declare in the xi plus yj plus zk dot here I j minus k. You will take dot product between xi into I means x y minus z is equal to 2. That's your Cartesian equation of the plane. Second, same here, xi yj zk dot 2i 3j minus 4k, and here also same simple dot product. 2 into xi means twice x, I and I square become 1 plus 3y minus 4z is equal to 1. That's your Cartesian equation of the plane. And same as students, given the third r dot, one of the s related equations, I just write the question please. S minus twice t I, next 3 minus t j, and 2s plus tk and is equal to 15. And very easy, just I mention in the form of xi, yj and zk. So here this I is a xi yj zk dot, and here students s minus 2ti plus 3 minus tj plus 2s plus tk is equal to 15 as it is. Simple, first with first only dot product. So my answer is s minus 2tx plus 3 minus ty and plus 2s plus tz is equal to 15, and that's your Cartesian equation of the plane. It is Cartesian equation of plane. Students, here Cartesian plane, you know that Lx plus My plus Nz is equal to D. Now question number continue students, fourth questions. In the given plane, find out foot of perpendicular from the origin. Yes, already you know normal form of the plane. That related question now I start here. But fourth is a IMP. Find the foot of perpendicular to the origin in the given plane. And in the given plane wise, our first question is very simple. Given the equations r dot, the given 2x plus 3y plus 4z minus 12 is equal to 0. 2x 3y 4z minus 12 is equal to 0. Students, very easy. Already I explained one examples in the last video, but here I just go ahead, same as to, that's your plane z, x and y. Consider here your one of the plane, and that is your straight way going. Here your point P is your foot of perpendicular from origin x1, y1, z1. So you are mentioned here, suppose P x1, y1, z1 is foot of perpendicular from origin is P x1, y1, z1. Very easy, foot of perpendicular formula, you know that LD comma MD comma ND, where LMN is what? Your direction cosines, and D is a perpendicular distance from origin. That's why I start to normal first. That's your normal. 2, 3, 4. Indirectly 2I 3j minus 4k, and its magnitude 2, 3, 4. It is 4, 9, 16 root 29. So you easily cover your n cap is a n by modulus n. It is a direction cosines. LMN value ready, and that's my answer, students. Here twice I plus 3j plus 4k upon root 29. That's why given plane, I just write down my given plane 2x plus 3y plus 4z is equal to 12, just divided by root 29 on both the sides. So we dividing root 29 on the both side to the given plane. So 2 by root 29x, 3 by root 29y, 4 by root 29z, and 12 by root 29. That is your finally our Cartesian equation of the plane related given. Compare with Lx plus My plus Nz is equal to D. So your final answer is ready. Required foot of perpendicular point is P x1 y1 z1, which is LD comma MD comma ND. That is your L, M, N, and that the D. So my answer is, students, 2 by root 29 into 12 by root 29 comma 3 by root 29, 12 by root 29, and last 4 by root 29, 12 by root 29, and my answer is ready. 24 by 29, next 36 by 29, and next 48 by 49. And here, a simple way, your first question is done. Now I going ahead, same parts the B. Equation of plane is given 3y plus 4z minus 6. 3y plus 4z minus 6. One more time check. 3y plus 4z minus 6. So suggestion seems up to that seems, only this I change. So drawing same, suggestion same, you write down, and the normal form is that here you can write down 0x plus 3y plus 4z, 0x plus 3y plus 4z is equal to 6, and that's the normal. You can write down 0, 3, 4, either 0i comma 3j plus 4k, 0, 3, 4, and simple way you take the magnitudes 0, 3, 4, it becomes 0, 9, 16, root 25 means 5. So n cap you derive after that, and given plane you divide it by the some numbers, and after that, students, comparing the values, easily get your answers. Other points are same. So n cap, which is n bar, our 0i, 3j, 4k, and what is the n modulus? 5. That's why your direction cosine is ready for downwards 5. So given plane I have to 0x plus 3y plus 4z is equal to 0. We dividing 5 on the both sides. So 0 by 5x, 3 by 5y, and 4 by 5z is equal to 6 by 5. And that is your, just compare with Lx plus My plus Nz is equal to T. Lmn ready, and last D 6 by 5. So required foot of perpendicular points LD, ND, ND. L I have 0 by 5, D 6 by 5. Same, M I have 3 by 5 into 6 by 5, and last 4 by 5, 6 by 5. So my answer is 0. 6 3s are 18 by 25, and 6 4s are 24 by 25. Very easily and very quickly, students, I will derive my answer is ready. Now question number, continue third. The C equation is x plus y plus z is equal to 1. Same is trying our plane 1x plus 1y plus 1z is equal to 1. Similarly, going students, the suggestion same, drawing same, up to that same, only you change the normal, and the normal is what? 1i, 1j, 1k, it means 1 1 1, its magnitude, so root 3, and going to n cap. In this way, simply you can derive that something dividing parts, and after that compare, and data is same as mentioned. So here n root 3, so n cap is the direction cosine, 1i plus 1j plus 1k by root 3. So in the given plane, 1x, 1y, 1z is equal to 1. What will you have divided? Root 3. Yes, on both the sides. So we dividing root 3 on the both sides of the above plane. So 1 by root 3x, 1 by root 3y, 1 by root 3z, and here 1 by root 3. But that's your equation of the plane in normal forming. So we compare with Lx plus My plus Nz. Lx plus My plus Nz is equal to D. L ready, M ready, N ready. So your foot of perpendicular required points L, 1 by root 3, 1 by root 3. Same. 1 by root 3, 1 by root 3. And last also same. Your answer is 1 by 3, 1 by 3 and 1 by 3. Now continue students, question number the fourth. Next one, 5y plus 8 D parts. Plane is given, 5y plus 8 is equal to D. One more time check, 5y plus 8 is equal to 0. 5y plus 8 is equal to 0. So I just write down similarly same steps, only here I mention in the standard form 0x plus 5y plus 0z is equal to minus 8. 0x, 5y, 0z, and 8 I will took the right side 8. Now I go to the normal. What is the normal here? 0i, 5j, 0k. It will 0, 5, 0. Take it modulus. Define the modulus value. It is 5. So after that you moving ahead in the way of your final suggestions wise, normal, n cap, and dividing equation is same as. So does this all points are same. Now n cap, n bar by modulus n, 0i, 5j, 0k, and n modulus is a 5. So in my given plane, that's my given plane, 0x plus 5y plus 0z is equal to minus 8. We're dividing both sides by 5. Yes, dividing 5 on both sides. So 0 by 5x, 5 upon 5y, 0 by 5z is equal to minus 8 by 5. And here you will stop. and that is represents Lx plus My plus Nz. So students, we write down, we compare with Lx, My, and Z is equal to D. And simple, going the answer, required foot of perpendicular Lx, LD, MD, ND. What is your L? 0 by 5 minus 8 by 5, comma 5 by 5 minus 8 by 5, comma 0 by 5 minus 8 by 5, and that becomes 0, comma minus 8 by 5, comma 0. That's my required points, foot of the perpendicular to on that. Now students, after ending our 4 questions, I going that now in the 5th way, same as question number 5. Also very interesting questions, but this time asking vector and Cartesian equation of the plane to having passing through given and normal given. So in question number 5, find, first of all, a heading written, find vector and Cartesian equation of plane having first one, given that passing through a bar directions 1, 0, minus 2 and normal n cap given, which is I plus j minus k. Very easy. Students, every normal is a perpendicular to the plane. This is a plane, that's your perpendicular. So I will just show that this is your plane, here your normal n cap, which is 1 ij k, I plus j minus k. Students, here that is a perpendicular to plane, and here consider your one of the points on A to P. P is a R bar, A is a bar. It means PA directions means what? PA means R minus either AP directions, that's perpendicular to N. So here one of the vector equation of plane, simple, your A to P dot N is a 0 because they are perpendicular. A to P is what? R minus A dot N, and R minus A is R same. A is that passing through 1i 0j minus 2k dot N is a normal, that's the normal, given that I plus j minus k. That's your vector equation of the plane. Students, you AP write down because I forward to A to P sides. Okay. Now one more, the Cartesian plane, Cartesian equation of plane. Same this equation, if I forward again, R minus A dot N is equal to 0, it is R dot N minus A dot N. In short, R dot N is equal to A dot N. Now putting down the values x, y, z. N is a normal 1, 1, minus 1. Same, A is a passing through that, given that 1, 0, minus 2, and N is again 1, 1, minus 1. And take down the dot product, you will get Lx plus My plus Nz is equal to D equation. So x plus y minus z. Here 1 plus 0 plus 2. So x plus y minus z is equal to 3. That's my equation of the plane, but Cartesian form. Now second, passing through, given that and with the normal. Second questions, exactly similarly questions are printed in your textbook. Yes. So passing through 1, 4, 6, and normal is given I minus 2j plus k. One more time repeat students, normal is what? Perpendicular to the plane. Yes, this is your plane, that's the perpendicular given that. So one more time I will show my drawing. Here your normal perpendicular to plane, and here I will show that one of the directions towards P to A sides, either A to P sides, they are correct. I write down A to P sides. So A to P side means this side you can draw the drawing, that one, because A and P on the plane, and that is perpendicular to normal. So here same is going to that vector equation of plane. Yes, A to P dot n 0. Why dot product 0? Perpendicular to directions. Now A to P is r minus a dot n. R is same, but A is students, simply you apply that 1i 4j 6k dot n is a normal I minus 2j plus k is equal to 0. That's your vector equation of the plane. Now if I further going to Cartesian form, yes, to Cartesian form, so I will write down r minus a dot n. So r dot n is equal to a dot n, and apply the value. R is xyz, but n students, that's the normal 1 minus 2 1. A is a passing through 1 4 6, and n is again that 1 minus 2 1, and apply in the students dot product. You will get very easily and very quickly your equation of the plane. So I will show just in the dot product. So 1x minus 2y plus z is equal to 1. Now 4 to the 8, and last 6 1 the 6. So x minus 2y plus z is equal to minus 1. X minus 2y plus z plus 1 is equal to 0. That's your Cartesian equation of plane. Cartesian equation of the plane. And very easily students, this question is fifth also done. Now here students, topic is continue for the question number 6. But before 6 I will show the topic. Topic is that equation of plane passing through 3 points A bar, B bar, C bar, having, I just show that x1 y1 z1, x2 y2 z2, and x3 y3 z3. Consider that you are one of the plane forming by the 3 collinear points. No, it is known collinear points: A to B directions, B to C directions, and C to A directions. And here consider one of the point P in general R bar. So you will show that A to P, B to P, and C to P having made one of the plane, but when ABC are known collinear. So equation of plane in this vector forming P to A directions, P to B directions, P to C directions is equal to 0. Otherwise, you can also write in the Cartesian form. This Cartesian form, x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and last x3 minus x1, y3 minus y1, z3 minus z1. If you decide derive, sure your answer in this form, just like lx plus my plus nz is equal to 0. So this related topic students, now we will start our question number 6. Find the equation of plane passing through given 3 points. Passing through given 3 points. But necessary you will check first. This point is what? Yes, non-collinear. Then they are available. So question 6. Find equation of plane passing through. First, question A that 1 1 minus 1, B 6 4 minus 5, and C minus 4 minus 2 3. Again check 1 1 minus 1, 6 4 minus 5, and minus 4 minus 2 comma 3. Students, I will first check given points is collinear or non-collinear. So first I will derive. Please consider x1 y1 z1, x2 y2 z2, x3 y3 z3, and go to directions. First of all, AB directions. So B minus A, 6 4 minus 5, 1 1 minus 1. My answer is 6 minus 1 5. Here 4 minus 1 3, and minus 5 plus 1 minus 4. Second direction BC, C minus B. So your C ready, minus B ready. What's your C? Minus 4 minus 2 3, and B is a 6 4 minus 5, and answer is minus 10. Next, minus 2 minus 4 minus 6, and 3 plus 5 8. Check, this is the opposite directions. Just minus 2 common take, 5 3 minus 4. So you will write down minus 2 with your AB for the cover BC. It means both have opposite directions, one going that sides, another this sides. Definitely it make to angle 180. It means it is collinear. So if you collinear, then how many plane derive? Yes, you correct thinking. It is infinitely many plane in this space. So here AB and BC have opposite direction. Therefore, A, B, C are collinear points. It means here infinitely many plane available. Therefore, infinite many plane available. Passing through A, B and C. So I not utilization this formula because it is collinear. If you know collinear, then I derive by this way. It is question number 2. So I go to now second questions. Same is moving slowly. I hope you understand properly. Point A, B and C, you will take x1, y1, z1, x2, y2, z2, and x3, y3 and z3. Point is that 1 1 0. Second, 1 2 1, and third, minus 2 2 minus 1. Again check 1 1 0, 1 2 1, and minus 2 2 and minus 1. Here also students, I will first check it is collinear or non-collinear. So my first direction is AB, B minus A, 1 2 1 minus 1 1 0. My answer is 1 minus 1 0, 2 minus 1 1, 2 minus 1 1, and last 1 minus 0 1. Similarly students, second direction is BC. So B to C, C minus B, you C, that B, and here you create your simple way your answer. And students, you check here it is collinear or non-collinear direction between AB and CD. So students, I derived that C minus 2, 2 minus 1, and B is 1 to 1. So my answer is minus 3, 0 and minus 2. Check. Having no direction are seen. So here AB and BC have in different direction. There is no common in between that. So at different directions. So confirm A, B, C are non-collinear. It means they form a one unique plane. That is the plane A to B, second B to C, third C to A, and that plane is derived by passing through general P R bar. R bar is a x comma y comma z. That plane is derived, that students. So you will write down therefore one and only one plane passing through A, B, C. So that's why I going now x1, y1, z1, x2, y2, z2, x2, y3, z3 equation of plane x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, and z3 minus z1. Students, you will put down in the answers, very easily answer you derive now. So just put the value x minus x1. What's your x1? Is 1. Y minus y1 is 1 and z minus 0. Continue now. X2 minus x1 is 1 minus 1, 2 minus 1 and 1 minus 0. Now x3 minus x1, minus 2 minus 1. Now 2 minus 1 and minus 1 with 0. Minus 1 with 0. 2 minus 1 and minus 2 minus 1. Students, I just calculate that determinant. My answer is here 0, minus 3. 1, 1. 1 and minus 1. So you will calculate by the process of definitions of determinants. Very easily you will derive your answer. So here first x minus 1, minus 1, minus 1, it is minus 2. Second 0 plus 3 and last 0 plus 3. Your answer is minus 2x plus 2, minus 3y plus 3 and 3z. So minus 2x, minus 3y, 3z plus 5, 3 and 2, 5. So my answer is 2x plus 3y minus 3z minus 5 is equal to 0. And here students, your this answers is easily 2x plus 3y minus 3z is equal to 5 printed in your book. Yes students, here I ending this question second, question number 6 to second. I will stop this video students, and this topic is over here, and further explanation same as I explain you in the next part for new parts. Bye bye.